welcome. This is the Working with Your Data. This is a deep dive on the FeatureLayer session that Jan and I present. Jan's lead developer on the ArcGIS API. I'm program manager for API and ArcGIS Online. And yeah, get started.
Let's get started. So we're going to cover, it's going to be hard to cover everything about the feature layer in 1 hour, but we're going to try to cover as much as possible so that if you are not familiar with the feature layer, you get a good view about like what it's capable of for you and how to work with that data directly in the web browser. So we're going to talk about the types of feature layers, how the feature layer is powered using feature tiles, different visualization styles, pop-ups, and we're going to show you a bunch of demos about how to bring those feature layers inside the web browser, inside your application. Some demos about labeling. How to query the different types of queries you can make on the feature layer, and how to interact with the data that is downloaded in memory. So the feature layer is, in general, it's all the types of layers that contain vector data and that we display in the browsers. So there are different types. We have the feature layer, that is the feature layers that are backed by feature services. We have feature layers that are backed by feature collections, which is client-side graphics, basically. And then we have other types of formats that we support, like CSV, and then the GeoJSON layer coming in the upcoming release of the API. Maybe, Jeremy, do you want to talk about?
All right, let's get into it. Start here. Oh, there we go. Okay. Okay. Talk just a little bit about feature layers backed by a feature service, and really this is the most powerful feature that we offer you. You bring your data into online or enterprise, and you host it as a feature service, and then it's easily accessible to the JavaScript application. But one thing I want to really just drill in on is the performance. So if you remember at the plenary, I talked about feature layers powered by dynamic feature tiles. Let me explain a little bit more what I mean with that. So here I've got a feature layer of county spending habits. And if I go to the data tab, just call out a few things here. Note I've got this date last updated. Make this a little bigger so you can see. 2/23. Just remember that date. Now let's go over and reload this page here. This is that layer loaded up on the client, and we've got the network tab open, and it's going to render. Notice on the network tab I've disabled the cache in the browser so that we can really just emulate like we were a new person, a new machine connecting to this service. And just a little bit smaller. We've got protocol buffer formats. It's over HTTP2, reduces the size, and we've got anywhere from a half second to a second and a half worth of time it took. And we see all these misses from CloudFront. Now let's reload this page one more time. Now, notice the time here. Nothing is more than like 380 milliseconds. And we see all refresh hit from CloudFront. That's because we built up this cache, and it's going to pull from that cache. It's actually going to still check back to the server to see if the data's changed. And if it hasn't, it's going to tell the CDN to load it up. If I didn't have this, to load it up. Now let's go back to that layer and make a slight edit to the data. Let's just change it to USA. Now notice that time changed to 2:35. I go back to this layer and reload it. What I'll see once it loads up here is miss from CloudFront These is now going back to the database, requerying it, because that layer has changed this time. Now, one last thing to call out. If you're going to share something public and you want the best possible performance, you should go to the settings page within your feature layer, your hosted feature layer, and look at the cache control setting. You can set this up to an hour. Make that change here and go back. If I look at one of these queries before I reload this page, I'll see this max age and S max age are both 0. Now let's reload this. Now, because I made that change to that layer on the server, that's going to invalidate the cache. And we see that with this misses. But if I look here, now I've got this S max age, which is how long it's going to be on the CDN for an hour, and then the browser max age, so an hour. Now, reload one last time. And what we should see, assuming the CDN is, as soon as the internet is still connected here. Whoa, really slow. There we go. All hits from CloudFront, and the time that it took to serve was 50 milliseconds. So you can really speed up the performance of your feature layer in ArcGIS Online by enabling that cache setting. But what that cache setting means is that if you make a change to that data, you won't see those results until up to an hour after you made that change in the data, because that's how long it's going to be cached at the CDN. So if your data is dynamically changing, like let's say every 15 minutes, set the cache age to 5 minutes. If it's not changing at all, set it to an hour. But just beware of that. Now this is right now in ArcGIS Online, and then in 10.7, hopefully 10.7.1, they are trying to build that into Enterprise. Okay. For visualization, we have a number of, we do a lot in the area of visualization. So whether you want to map by location only, do thematic, look this up just a little bit. Thematic-driven symbolization based on fields in your data, or you can use the arcade expression language to customize your data and then visualize it. We still recommend that you use ArcGIS Online tools for the most part to author your map, because it's going to be easier to get your dynamic visualization correct using the out-of-the-box tools and the smart mapping capabilities. And then you'll be able to load it with just a layer item ID, and Jan will show more of that. If you're building an exploration app, API supports all of these tools to generate good defaults for you based on the different types of visualization styles you're interested in. And then you can manually define the render yourself in code. If I just quickly look at this one. We have a lot of really good documentation in here that gives you an idea of the different types of visualizations. These are all done through some combination of the renderer plus visual variables plus arcade expressions and so on. We won't drill into too much of this because there's a session right after this in Catalina, Madeira, where Christian and I, mostly Christian, will lead you through on all the different types of visualizations you can create with the feature layer. Next is on pop-ups, and for pop-ups we have a lot of good rich content in the SDK that you should call your attention to. Just search for pop-up in the sample search. And the pop-up, okay, let's look through the pop-up. So the pop-up has a title and content, and this pop-up template, you can define it with the title and content. So here we've got this example here. I've got the title of the pop-up, and I can say these are the different fields that I want to view, control the labels, and you'll get a pop-up like that. Pop-up's responsive, resizable, you can dock it in different places, and you can do custom formatting on the fields as well. You can also use that pop-up template with the feature widget. And so in this case, it's popping out as I move my mouse over down at the bottom. You can do custom actions with your pop-up, like this example, which allows you to put your own custom tools in it. So now it's going to measure the length of that line using the local geometry engine that's in the SDK. So pretty expressive. And just like with renderers, you can author your pop-ups in online, and they'll just come with the layer if you bring them in from your portal ID. A new feature at 4.11 is the ability to work with the latest generation of Arcade that allows you to do feature sets. So, oops. Where did my sample go here? I close it. Let's load this example up. Or first, actually, I'll just explain it. Okay, so I've got 2 layers in my map that I loaded from Portal Item, and I've got my pop-up template with a custom, with the title, and this is on the county layer, and it's pulling the attribute county and the attribute state. But then for the content, it's actually pulling something that's referred to as churches, that's referred to this expressions name. So under expressions info, I've got my name defining it, and then I've got the actual expression. This is the Arcade expression, and I've written that up here in this script tag. And this is using the new feature set capability of Arcade. So that allows you to work with other attributes and features outside of your current pop-up. So I've got a feature set by name, so that's going to pull out this US church place names. If I look down here, that's the title of this layer, this feature layer right here. So it's going to, when the pop-up's on the county layer, it's going to reference features in this church place names layer. The county layer gives me the FIPS code. I do some data mangling so that I can filter the church place names layer by the state ID and the county ID. Then I'm going to just do the count based on this current county. And that'll give me the number of churches. And do a simple calculation here. The population divided by the number of churches, so that I can do the church per capita formatted this way. So if I click on one of these guys, it's accessing this churches layer, and
make it bigger.
Oh yeah, this church layer. And so I see that the number of churches here is 47, and the number of people is 724. And just to show you that that church layer is there, as I zoom in, that layer should turn on, unless I lost. There we go. There we go. So this pop-ups with feature sets allows you to reduce the number of pop-ups that you have in your application. So you can think of it effectively, you could just have one that drives everything, and you pull the information from whatever layer you want to put into that one pop-up and work with it. Okay.
Yep. So now I will cover the different ways you can bring the feature layer into your JavaScript application. So the easiest way is to point directly to the feature service URL. So you create a new feature layer with a URL, the layer ID inside the service. If you don't specify the layer ID, we'll just pick the first one, so 0. And then the different options like renderer or popup. So I have this example. So let me go over like how I built that map. I created a base map, and I created like vector tile layers. So base layer for my vector tile base map. So it's representing the oceans and the land features. And then the reference layers, which are layers that are put on top for labeling, for example. And then here, I declare my feature layer. So, and I set this URL so we can just like open it in a new tab to see what's there. So you have a description here, the household income in the past 12 months. It's point data and so on. So some information. Then I just add, I create my map with that base map and this layer. So that's nice, but then, so the layer comes with a default rendering in this case, but if I wanted to specify it, I would have to declare my renderer and my pop-up template in the feature layer declaration here. What is also very interesting with the feature layer is that you can specify a definition expression if you want to limit the amount of data that you want to bring to the web browser. So this is a where clause. So in this case, I just want to see the features that are that have the attribute state name equals to California. And so we can try this URL, this query that it's going to make directly on the feature service. If you go to your layer, and then right at the bottom here you have all the fields. We can see that I have a state name. And so if I go to the query page here, I can say, well, for now I'm just going to return everything. Oops. What? One equals one. So, oh. So we can see that we have at least 300 and 3,500 results, but let's say I want to now limit the amount of data I want to bring back. I would just say state name equals California, and go back again, execute. Now we still have more than 3,500, but it's definitely less than the original request. Anyway, so if I specify now, I only get that subset of features, so it's going to be easier to work with and less data to transfer also.
Question, Jan. There was a ton of attributes for that. Are they all going to come down?
Nope, so I have a slide for this.
Oh.
So the definition expression is great to only focus on a subset of features, but also it's interesting to clean up the data that comes back if you are interested only into features that have proper attribute set. So sometimes some features may have like null values. You can like just remove, filter that data directly on the server side. Now, let's say someone that has more cartographic knowledge, like Jeremy or Jim there, you can configure on ArcGIS Online directly your renderer, and you can easily, instead of me having to configure all this information, I can bring my feature layer using the item ID. So if we go here, on ArcGIS.com, we can open that portal item by ID, and then you have like more description, more information about this data and how it was built. Yeah. And this layer was previously configured with pop-up information and renderer information directly in ArcGIS Online. So me as a developer, I don't have to care about like how actually the data is made. I just have a very nice map out of the box.
Yeah, and that's the same for the pop-ups, everything. Definitely, that is the easiest way to go. Definitely recommend that.
Yeah. So in this case, there is a custom pop-up template with relevant information. Okay, and so to do this, yeah, I just copy and paste the item ID, and I reference, I create a portal item on my feature layer, set the ID, and then automatically this comes back. So it's a much shorter code to write. And here also we can see that the base map, which is the exact same one as before, instead of creating 3 vector tile layers, I just reference the item ID of that particular base map.
The other thing this gives you is if you're going to make an app, and the person you're making the app for is the cartographer, you know, you could have that guy come over or lady come over and tell you exactly what they want. You know, or you could say, oh, just give me the layer you want and stylize the way you want it, and then I'll build it into my application. I know that some cartographers at Esri, like Jim Harries over here, does that all the time. That is a way to minimize your work.
And finally, the last way that we have to bring a feature layer inside the API is using, you know, like sometimes I don't know that a particular item ID, what is behind? Is it a feature layer or a tile layer or a map image layer? You can use the API called from portal item. So you import the layer class, and then there is a static method called from portal item, and with the item ID. Automatically, we will load that portal item under the hood, figure out like what type of layer it is, load that layer file, create the layer file for you. In this case, this layer from the Living Atlas team, it's actually a group layer with 3 different geographies. We have the state, data at the state, we have data at the county level, and then we have data at the census tracts. If we debug this application, we're going to see that when the layer gets loaded, I get in my layers here, I should have some layers inside. Well, they're not there yet, of course. Okay, yeah, the layer is not loaded at this point. It's only just the group layer with the 3 layers inside. But yeah. So it's even more convenient for you if you work a lot with Portal. It's very important to use this concept of Portal item IDs instead of pointing to the URLs. Okay, so this is what I just covered. Okay, so a breaking change in 4.11. So if you are using the feature layer, it's pretty important. We used to fetch, with each feature, we used to fetch all the fields that were required by the pop-up template to be able, when you click, to get the pop-up showing up with those fields. We refactor the pop-up, how it works, and now the pop-up will look at the feature that it needs to display the pop-up for, and if it doesn't have all the fields, it will fetch automatically those fields. And based on that, we decided to stop fetching the fields for those features, because let's say if I have 500,000 points, and then for each of the points the pop-up template says I want to display all the fields, then we bring literally like like tons of fields that the user will never see because they won't click on 500,000 points, or maybe they will, but it's very unlikely. So
yes. What you'll see is the attributes can really bloat up that payload response. That can be even bigger than the geometry, especially for points.
So the benefit is really that we have less data to fetch, so it's going to come faster to the web browser, and also to decode and store in memory.
Just to follow on with that feature tile thing at the beginning. So if your app requests data for a certain set of fields, and then you add another entry into your pop-up, or you add another field that you're going to visualize on, then it's going to change that query because it's going to have a new field. That will be cached independently from each other. So it's kind of the beauty of the feature tiles is that you don't have to think about what's being cached or how it's being cached. It's all taken care of under the hood. But you have the flexibility of using whatever data you need whenever you want. Versus like kind of vector tile approach where you are burning those attributes into the vector tile. And so if your app changes and you need to access some other attribute, you need to recook those tiles.
Yep. So the way to migrate to 4.11 will be if you really need to have those fields, sometimes you need those fields basically if you do client-side querying, you may need to have the data already on the client. So in this case, you will have to access the layer once it's loaded and specify the out fields to make sure that the fields that you are using client-side are downloaded with each feature.
Now is the out fields here this plus whatever the layer is using?
Whatever the layer needs to render, so the fields from the renderer, the fields for labeling, fields for elevation info, for example, plus what the developer specify in out fields.
And then one last thing, you'll also analyze the arcade expressions and pull out the fields with one caveat. That if you are programmatically generating your field names, we can't resolve those in arcade. So you'll need to explicitly put those fields in your arcade script so that they get pulled in or specified this way.
So labeling, pretty important also. Once you have like those features, it's nice if you can give a little bit of information on top of the rendering. You can show attributes per features. So the way to do this is by specifying on the layer labeling info. Same, this can be configured on arcgis.com, and then when you load by ID, you get all this information there. But then you can specify labeling info. It's an array of label classes object, and in this case, I want to display. I don't remember which one. Oh, okay, it's using an arcade expression in this case. So it's showing like the wind direction and the temperature, and also some name. And then it displays in text in multi-lines. This is an enhancement at 4x. If you are familiar with 3x, it's only on a single line, the labels. So now you can do multi-lines. So it's pretty nice because you have like the labels generated on the fly. They are deconflicted on the fly. We support currently points and also lines. We support all types of geometries. Yep. The other example on labeling, so this is an example from the SDK. This other example is like we have all this temperature information, I think, around the globe. Here I don't have any labels, but then when I zoom in, I get temperatures, and then based if they are, so it's in Fahrenheit, so if it's below 30 degrees Fahrenheit, it's going to appear in blue. If it's above 32, it's going to be in red. And for this, it's the same. There are arcade expressions and then different label classes. So you can define different label classes, on the feature, the labeling info. So in this case, we have a label class for the blue ones, a label class for the red ones. But then what's interesting is like when you zoom in a little bit more, you can also define a scale range. So at small scales, you can display some label, and then when you are reaching a certain scale, when you have less density on the features, you can display more label classes, for example, per feature. So here, each feature has 4 different labels placed at different placement on the feature.
Could you go back to the 2 label classes?
Yep.
In the code, sorry.
Okay. Sorry.
In this code, just scroll up.
Just scroll up.
Yeah. And, there it was. You just pass it.
Look
Cool. So see the where clause there? That's any where clause, right? Any SQL where clause.
Yeah, any SQL where clause. Mm-hmm.
So that's just an important point that whether it's arcade or SQL, we can do those completely on the client.
Yeah. Yeah, in this case, the arcade expression is here to generate the text, and the where clause is here to filter whether or not there is that label class for a particular feature.
Yep.
So now I'm gonna go over the different methods you can query the data. First, very simple, it's called query features. It's the fastest way to access the data. So on this little sample application, I click on one of those features, and then I show the attributes inside a popup. So I have my feature layer defined here. I specify, like I said before, the fields that I want to come back. In this case, I want to display all the fields, so I just put star. It's a specific name field, and then on each click, when the user clicks, I will call query features. Right. So my query features function here convert the screen point to a map point. And then I call query features. So what is important is to pass a geometry, because in this case I want to do a spatial query. So it's going to be my map point. I want to intersect with the data. I don't really care about the geometry. I already have it, and I'm really only interested into the fields, and then I will specify the outfields. And so you get back a feature set. A feature set has many information. It contains the field information again, but then more importantly, it contains the features. So in this case, I will only, I will only have one single polygon, and then I call view.popup open. I pass the location, which is the point the user clicked on, and then the features array that came back.
And if you're doing the query features on the layer, it's always going back to the server.
It's only, yeah. So if we go here, I will click. Yeah. So we have this query that I just wrote. So the parameters that I passed are serialized here. So we have the point, and then my special relationship, intersects, and so on. And the result comes back in JSON format. We have like the one feature I clicked on, and then all the attributes coming back. Now, another type of query you could do is, so you have different spatial relationships. You have intersects, you have contains. There are like 10 of them or something. Is to query by distance. So it's very handy, especially when you have points, or when the user has, users, they have a big, everyone has a big fingers. You want to, for example, query like a little circle, little buffer around that point where I clicked on. So in this case, I will use query by distance. The same type of, it's still query features, but then I will specify my point, I click, and the distance. So here, in this case, I want to query 1 kilometer around the feature, around that point. So it brings back a lot of features, and they are all scattered around, but you have to imagine that it's that kilometer buffer around it. All right. Yes, in 4.11, we are adding a new property called return query geometry. So it's going to be on hosted feature services. If you pass this Boolean to true, then the feature service will bring you back the actual buffer polygon that he used to perform the query. And when it comes back, it's commented here because it doesn't work on production yet. When it comes back, you have access to that query geometry, so you can use it, for example, to give some feedback to the user about like what type of special query you just made.
That query plus distance is really useful because it's works with any geometry type, whether it's point lines or polygons. Yeah. If you do a negative distance, it's inside. So it's very powerful and simple, and it's not computing the buffer on the client. It's actually just sending the geometry plus whatever that distance and distant unit is, and then on the server it's generating.
Yeah.
Question: if you're taking them, are these all client local queries against features that are cached, or is this around?
No, in this case, it's always for now. It's always going to the server. I will show like some client-side queries after. But those goes all the time to the service.
Layer query features is always to the server.
Yeah, always, all the time.
All the time. And we'll get to the client-side queries a little bit later.
So I'm missing one. Is it this one? Oh, no. Sorry. Pagination. No, it's good.
Time.
Yep.
Plenty of time.
So let me close this. Okay. So pagination. Sometimes you have like services that contains a lot of features. In this case, I have all the cities of France. It's about 36,000 polygons. If I make queries, so for display, we make queries, but they are really optimized. Like I said, it doesn't fetch all the fields in this. Probably here, it's like only one field. The I don't remember. It's here. The median, the disposable income, median disposable income. So we only bring back the object ID with each feature plus the median income. But let's say you want to have this type of grid with all the features. So here I have lots, and then as I scroll, you can see that it disappears because I don't fetch all the features. But then as soon as I stop, you get a feature. So what we do for that is we have this grid, this data grid, and then we do fetch on demand by pages. So we say, okay, fetch me the first 2,000 features, and then after, when I keep scrolling, I will fetch from 2,000 to 4,000, or 10,000 to 12,000, and so on. So let's go over how I build this. So I have my function called create grid. I load my layer, and then I create the columns for the layer. I have this convenience function to convert a feature set to the rows for the grid. And then in this case, I'm using dgrid, which is a third-party library to create tables. And then this grid needs a store. So the store contains either contains the data or can be an on-demand store. So to create that store, I create a subclass of the base store class. And then the important part here is that fetch range. So every time I scroll, and then when the grid doesn't have the data, it's going to call on that fetch range, and it will give me two information. Fetch me the feature from this index to this index. So I call query features again, and then I pass two parameters, two new parameters. So it's called start, the first, and num. And num is basically the amount of features that to download. And then again, I pass my star as outfield. So every time that query features ends, we convert that to rows, and then we return that query results, which is a dgrid specific API. And to this also, I pass the total number of records that there are in the service. So anyway, really simple. The on-demand grid is that dgrid that I'm using. I pass the columns that I want to show, and then the minimum rows to fetch per page. So dgrid decides whether, how much he wants to fetch. So 500, and then I specify the maximum number to fetch to the max record count. Max record count is a property from the feature layer. It tells you how much data the service can return you at once. If you ask for 10,000 features, it just won't go above what is specified. It's a service property. And so, yeah, I create my grid with those two properties and the feature layer store that I just created. Cool, and yeah, that just works. We could go continuing adding implementation like sorting and filtering and so on, but in this case, I just wanted to display.
Yeah, the pagination works with the sorting. You do have to be careful with the pagination with like enterprise feature services. So working with SDE, you ask for 200 back, you may not get 200 back. You may get less back. Just because of the way the queries work there.
Okay, so another type of query you can make on the feature layer is called query attachments. So you can enable attachments on your feature service. So meaning that for each feature you can attach different types of files like pictures or PDFs or like pretty much anything.
Yep, almost anything.
Yep. And so each feature, so the feature layer will tell you if it supports or not attachment. There is a very important, let me go to the documentation, a very important property that you need to check out. It's called capabilities. It's available on each layer implementation, like a lot of the layer implementation. It's a big object that tells you what that particular layer is capable of. So for example, if the service has attachment, the capabilities.data that support attachment on the layer will be true.
Yeah, if you're building a generic app that can take services from different feature service implementations, you definitely would want to get to know this because not all feature service implementations have the same capabilities. And this is the way to understand what's supported. Definitely don't use the version number to make that choice.
Yep.
You want to use it's very fine grained, even like query with distance.
Yes.
That is also a property that's exposed.
Yeah. Let me show this one. So we have the editing, query, supports query attachment. And then, yeah, supports distance.
Yeah.
So if the layer says false here, don't try to make a query by distance. It's not going to work.
And it may look like crazy complicated, but it's actually really good if you're building a generic application to know what the service can do, so what you can offer your users.
Yeah. We try to, like, for example, support centroid. So if you have polygons, you can say on your query, you can say also, I'm interested into getting back the centroid with my data. Sometimes we try to bring some more information, like it's only supported in ArcGIS Online hosted feature service. But yeah, like the way to build generic apps is to check on that capabilities object. But in this case, I already know that my service has attachments, so I don't check anything. So the difference here is like when I will click, okay, so when I will click, I will display the image. It's only that feature that has an attachment here, but it has this tree picture. So to do that, I get again the map point. I do my, I do my query. So in this case, I use query object IDs because I don't really care about the attributes of this particular feature I'm clicking on, but instead I'm just interested into the object ID. So I pass my geometry, same, intersect, and then I get an array of object IDs back. So since it's a polygon, I will only always get only one object ID if I click on a feature. And then what I do next is to call for query attachments. So query attachments, here I'm only interested into JPEG files. You can filter, you don't have to. You can specify or not if you are interested into JPEG files or PDFs and so on. Yeah. And then the object IDs of the feature I clicked on. So then I get back the map, an object that maps from the object ID to the list of attachments for a particular object ID. So I go over all the different object IDs. I get the attachments for a particular feature. And then, so here I'm logging that into the console. But then I also create an image element, set the source of the image to the attachment URL, and then just add it to the DOM.
You scroll up just back a little bit on the by IDs. Yeah. So the query attachments by object IDs, so that means you can specify multiple. So if you're going to go back to Jan's paging app that he was doing, if he wanted to have another column there that showed, how many attachments for each feature are there, he could, after he made the query features request, he could take the object IDs that were used and then pass them here to the query attachments, and then be able to pull out what the count is for each of those and plug it into that table.
Does this also work if you're attachment by linking by global ID? Does that matter?
No, it shouldn't matter.
By the way, I just told, right before we started, I just told Jeremy that this layer looks horrible, and he told me that he did that layer 8 years ago. All right, and
we need more layers on our SDK team. So.
Yes, and the last one is related features. So this is in the case where you have a layer, and then for each feature you may have like one or multiple related features. So in this case, each of those polygons, they have trees that are referenced. I think it's trees.
Trees.
Yeah. So you can. So the layer has related relationships. So let's go here on the doc page. Okay, so the feature layer has relationships. So when the layer is loaded, then you get this array of relationships. And a relationship is basically an object with an ID. Doesn't really matter. And then the related table that is really what we want to. It's basically the ID of the table that we have to query. We have the key on which that relationship has been made, and the cardinality, so it could be one-to-one or one-to-many. Sorry. Let's take a look quickly at the service so that you can see where to look for this information if you have a service. So if we go to the service page, and if you scroll, you will get to the point where you have the relationships, and then I can click on the relationship, and so we have the different fields. So in this case, you have the tree fields, the minimum. Yeah, I don't really know.
So those are blocks in Beverly Hills, and those are the number of their trees, and then it's the aggregation of the trees to the blocks. So what's the maximum height, the minimum height, average height?
Yep. And so if I click on one of these features now, instead of displaying the list of features in my grid, I'm just displaying the list of related records. Okay, so for this, I call again query object ID to get the feature I just clicked on, and then I call query related feature, and then I will specify the relationship I'm interested in. So the first one, and then the object ID, which is the feature I just clicked on. What I get back is very similar to attachment. I get an object that has, by object ID, you can get all the related features. So here for, if we debug quickly, for the ID, for this ID, then I get back my four different features.
Same thing applies on the to attachments as to related records. So you can, if you wanted to put the count of number of related records in your feature table, you could, page, get your 25 records, and then query for the 25, those 25 records, find all of their relationships, and then you'll get each features back, and then put the count in the table.
All right. And so the last part for today, we're going to talk about how you can interact with the data that is in memory. So since we downloaded already all the features client-side, we implemented a client-side query engine to be able to execute queries. And we support almost everything that the server can do. We can do it client-side. There are some limitations that you have to be aware of. You only can query against what is on the screen. So, for example, for polygons, we don't ask for the fully detailed polygons. We ask for to have the geometry in a simplified fashion, so that you have less vertices to draw. Because if you have like very close vertices on a polygon, then when you are very zoomed out, they all collapse to a single pixel. So it's called quantization. So we define some parameters so that we can lower the amount of vertices that we get back. Otherwise, it would be like megabytes of geometry that is virtually useless. What does that mean is like if you do sometimes like vertices, they move from one pixel to another. So if you do some intersection and it has to be really accurate, the only way to guarantee this accuracy is to go to the server. But then sometimes you can also use the client-side one if you are not too picky about that.
This is very important. If you're querying the layer view, you're not working with the original source geometry. So you need to be very careful and don't launch missiles with those coordinates.
Yes. Okay, so this application I have it's a power plant information. So we have different types of power plant. We have coal and gas and oil. And so what I want to be able to do is to get some information about the average capacity of those power plants. So I use the sketch view model to be able to draw a circle. So I'm drawing a circle, and as you can see, as I update, as I update my circle, I update that chart that gives me information. So here it's clearly like nuclear. That is the most used type of energy source. I can go to France again, and then like here again, nuclear. And so this is happening like all on the client. It's really great. And in this case, it's perfect for our use case. We just want to have a rough estimate about like something that is in a circle. There is no like nothing needs to be accurate there. But The advantage is that for the user, he can here I'm drawing a circle, but you could imagine doing a query by distance as I move my cursor and get instant feedback. So for this, okay, let's go a little bit over the code. So I have this web map loaded by a portal item. So in this case, I just have one portal item ID, and then there is a bunch of layers coming in. I load all the layers. So there is a method on web map to load everything. And so I grab my feature layer of those power plants, and I specify the outfields I want to make statistics on. So here I want to ensure that the fuel type, but also the capacity are in megawatts, are coming back with each feature. So I set my map view, and then I set up my view model for my button here on the top left, where I want to draw on the graphics layer, on the view graphics, and then my polygon symbol that will represent my circle here. Then I have the different fuel types. I could make the app more generic and then read the different unique values. But in this case, I know already the values, so I've hard-coded them. And then the default data for my chart, so all zeros. And it's using chart.js in this case to draw the chart. We specify the different information about the background, the color of the different bars, and then some different options. And so when the layer is added to the map view will represent that map. For each of those layers, it will create a layer view. So to query client side, we will use that layer view. So for that particular feature layer. So to access the layer view, you wait for the map view to be ready. And then we get the layer we are interested in. Then we call when layer view. And so when layer view will wait for the layer view to be created for that particular layer. We have the layer view. And so a sketch view model, when it will emit a create event every time I will move my circle here. So every time I will make my circle grow or shrink, I will call that select feature. And so I wire that when I click on that button on the top left to create that circle. So select features, take the layer view and the geometry, which is that circle, and it will call create query on the layer. So create query, it's a function on feature layer to create a default query for you. If you have defined a definition expression on the feature layer, it will set that definition expression on the query and return you that query. And so here I'm interested into that circle geometry and intersect with that circle. And I will define an out statistics field. So this is where I can define the different statistics I want to get back on my data. So here I'm interested into doing statistics on that capacity. And then I will give it a name. So it's the average capacity in megawatt and the type of statistics. So you can do a count, you can do a mean and max, average, standard deviation.
Oh, that's why nuclear is at the top of everywhere, because it's the average.
Yes,
and
it produces a lot.
Yeah.
And then I will say I will grow by the fuel type. So when you go by, then you will get one value of capacity of the average capacity per fuel type. For the available fuel type. So if you don't have nuclear in one region, you won't have any information about those statistics. And then I will also use the new 411 API called effect to put a grayscale and an opacity effect on all the features that are not part of that circle. And so for this, I define my effect I want to apply, and then the filter. So the filter is basically it's like a query, and I will say that everything that is inside my geometry and that satisfies the definition expression won't be affected by the excluded effect, and so all the other features will turn grayscale. Make sense?
Yep. And that query features where he was computing the statistic query, that would be the same if you were doing query features on the layer. It would go to the server and do it. But here it's doing it on the client side. And it's really important to leverage this as much as possible, because what you're really doing is you're bringing the data from the server to the client, and then the client, all your clients' browsers are doing all the work. Versus if you had an app that's always going to query for statistics on like every map extent change or view change, then you're going to always be pushing that query to the server, and the server is going to be doing a lot of work. So you really want to leverage this, if possible, to build your sort of dynamic indicator type applications.
Yes. So let me do something. I will just run it client on my machine just to show you what else we could do. Instead of using effect, we could use another property called filter. So if I do filter here, and filter is a new property to to completely hide features. So let's do that instead of effect. If I reload my app, and now if I draw my circle, only the feature inside that circle will show up. It's pretty neat. And it's really fast also, so it doesn't catch up. Anyway, so let's go back to effect. You can play with different type of effects if you prefer something like sepia. We can do sepia 100%. The goal of these effects is really not to change the meaning of the rendering. So here we are still attached to, we still want to show those different colors based on the fuel type. But it's interesting to give like some effect for interactivity, right?
Yeah, it helps you really emphasize the features that are important and de-emphasize the features that aren't. And you have full control, right? You can do either the inside or outside.
Yes. So we can apply an effect on the excluded feature. We can also do one on the included effect. So let's do something that you shouldn't do, which is, let's say, rotate the U. So you rotate, which will change the color on the color wheel. So by, 45 degrees. Don't do that.
Yeah, with great power comes great responsibility.
Yeah, so we are still working on the documentation for this, and so we'll try to give some guideline about how to use it. So so I don't know if you saw, but the inside features are definitely they completely, if we look here, it's yellow in this patch, but now it's completely it's green. So it's because I've rotated the colors.
Yeah. Don't become the next blink tag.
Yes. So anyway, so passing on the effects here, to get the statistics, I call query features, and then I will map those features by. I need to format that for the charts. So I will use this map of stat by fuel type, statistic by fuel type. So for each of those features, I will get the fuel type, and then I will get the computed average capacity that I asked for. So then I will set the fuel type for coal, for example, I will have a certain value. And then after I will go over all the fuel types that I want data for, and then I will check, do I have a statistic for that particular fuel type? If I don't, I will set 0. And then I use the ArcGIS API to update the chart. And then, yeah, that's
cool.
That's what we have for you today.
Any questions? We got 2 minutes.
So I'm not familiar with the syntax for those effect strings. Is that?
So okay, so it's not released yet, but if you go to, it's inspired by the CSS filters. So the effect is going to be a string like this. So you have contrast, grayscale, you rotate. This is what basically I just used. The ones we don't support is blur for now. We don't support also drop shadow for now, and we won't stick to just color effects. We want to in future releases to add a scaling effect or rotation effect. Yeah.
Is there going to be a functional way to build those properties?
No, it's going to be a string. It's going to be a string.
It's
Yeah.
just like we want to keep it similar to the CSS syntax. Go in the back.
Is the filter available in 3.28?
Is the filter available in 3.28? No. And then it won't be in 3x.
You guys spell out in the documentation with 411 all the intricacies of how outfield works?
Will we spell
Yes.
out in the documentation how outfills work? Absolutely. 'Cause it is very confusing. And 411 will have feature layer support for table, right?
Yes, yes, yes.
For table only?
Yeah.
It was a question you asked, right? Support for tables? Okay.
When you were talking about the fields that they requested, will it not honor the web map pop-up definition for the fields displayed?
Question was on the fields. For what fields come back, will it honor the web map definition?
Yeah. So when the user will click, and then if we don't have the fields that are needed for the pop-up, we will fetch, like the pop-up will fetch automatically those missing fields.
So the pop-ups will work.
Yeah.
It'll be fine. You don't have to do anything. But if you are expecting those fields that are just in the pop-up to be able to query on them on the layer view, then you need to explicitly say you want that back.
In the layer view, when the simplification, did you say there were parameters that could be adjusted, or is there some more information?
For the layer view simplification, are there parameters? Not for the feature layer. Feature layer's got its own, it's just going to do it. It's basically going to take the resolution of the screen and control that.
It's based on that.
Yeah. So it's like the view resolution, which is the number of map units. So let's say meters per pixels, and then we use that value for 1 pixel, and then we send that quantization parameter to the service. And actually, I could show.
Basically, we don't want no more than 1 vertex per pixel. While John's looking that up.
So in terms of you come up against a maximum record you can store in the layer view,
Maximum.
like a measure the cache, right? So I mean, it must be like a sort of top out and say like 500,000 records.
It's we currently don't have hard limits. So if we manage to download, like the limit will be the amount of memory that the browser can take.
Yeah, I mean, the price is like how does the performance start to not great? What's the next one?
I think it depends on the device you're on, what it has. And then we have a spatial index, but we don't have an attribute index. So if you're doing queries, attribute-based queries, and you have a lot of data, that's going to be slower.
Yeah, it's going to be a full scan on all the features. So, yeah, if you use a geometry query, it's going to already really limit the number of features, and then yeah. So here I can show you quickly the type of queries we send. So for a particular feature tile, we specify the extent, and then we specify the extent called quantization parameter, which is also an extent basically of the quantization information. So the tolerance here, 611, is 611 meters per pixel. Yeah.
Cool. I think we're over time, so thank you.
Yep.
Okay, let's run to the